What is reality? It is a question so simple that a child can ask it, yet so deep that philosophers, scientists, and poets have wrestled with it for thousands of years. When you touch the ground beneath your feet, when you breathe in the air, when you look up at the stars, what exactly are you experiencing? Is it an objective, solid world out there? Or is it a constructed theater of perceptions, shaped and filtered by your mind? For most of human history, reality seemed straightforward. The earth was under our feet, the sky was above, the sun and moon traveled predictably across it. Objects fell when dropped, fire burned, water flowed. To the naked eye, the world was made of solid things. Reality was what you could see, hear, touch, and measure. But the deeper we looked, the more elusive it became. When the Greek philosopher Democritus proposed that everything might be made of invisible atoms, he was not just offering a scientific idea, he was challenging the very fabric of what people thought reality was. If the world is made of tiny, indivisible pieces, then what we see is not the true essence of reality, but an arrangement of something far smaller, hidden from the senses. And yet, Democritus could not prove it. It was an act of imagination. 2,000 years later, science caught up. And suddenly, the atom was not just a hypothesis, it was measurable, it was testable, and it was real. But here lies the first twist. Once we could actually look inside the atom, it shattered our common sense again. The building blocks of matter were not solid, indivisible marbles. They were mostly empty space. A nucleus here, an electron there, and vast nothingness in between. If atoms make up all of us, our bodies, our cities, our planet, then reality is not solid. It is mostly void. This was just the beginning of the unraveling, the collapse of common sense in the 20th century. Physics cracked open reality further. Quantum mechanics revealed a universe where particles behave like waves, where probabilities replace certainties, where observation itself seems to influence what is real. Imagine this. Until you look, an electron does not occupy one position, but many possible ones. Reality waits in suspension until measured. That means the world beneath our senses is not things at all, it is possibilities, potentials, probabilities. And when consciousness interacts with it, something definite emerges. Suddenly, reality is not passive. It dances with the observer. This is where philosophy rushes back in. Are we discovering reality as it truly is? Or are we co-creating it through the act of observing? Is the cosmos an objective machine, or is it an interactive play between matter and mind? These questions are not abstract. They determine how we understand ourselves, our place in the universe, and even how we build technology. Quantum mechanics, after all, is not just philosophy, powers the semiconductors in your phone, the lasers in your devices, and soon, perhaps, the quantum computers that may redefine knowledge itself. So here's the paradox. The most practical science ever invented is also the one that tells us reality is stranger than anything we can imagine. Why ask these questions now? You may wonder, why spend 3 hours diving into this? Why not focus on practical, everyday matters? The answer is simple. Because reality is the ground of everything. Every decision, every action, every dream we pursue rests on an assumption of what is real. If our model of reality is too shallow, we risk misunderstanding not only the universe, but ourselves. Consider this. We live in a time when science has mapped the human genome, peered into black holes, and built machines that can imitate human thought. And yet, at the very foundation, we do not agree on what consciousness is. We do not know why there is something rather than nothing. We do not fully grasp whether time is flowing or if it is a static dimension our minds happen to move through. In other words, the biggest breakthroughs only deepen the mystery. Reality is not just a background stage, it's the main character. By asking what reality is, we are not indulging in abstraction. We are addressing the most fundamental question of all, the two lenses, science and philosophy, to explore this question. We need both science and philosophy. Science gives us data, experiments, models that predict and explain. Philosophy gives us frameworks to interpret those models, to ask what they imply about existence, meaning, and truth. One without the other is incomplete. Pure science without philosophy risks becoming blind data collection, facts without meaning. Pure philosophy without science risks becoming speculation untethered from reality. But together, they form a bridge. For example, when quantum physics suggests that particles exist in multiple states until observed. Philosophy asks, what does that mean for the nature of reality itself? Is the universe deterministic, probabilistic, or something entirely different? Does consciousness collapse the wave function, or is reality branching into many worlds simultaneously? These are not questions science alone can resolve. They require us to step into the deeper, often unsettling waters of philosophy. Reality as a mystery we can engage with. Let's pause here. It is tempting to think of reality as something we will one day fully solve, like a puzzle with a final piece. But history teaches us otherwise. Each time humanity thought it had reached the foundation, the ground gave way beneath us. We thought Earth was the center of the universe, was not. We thought atoms were indivisible, they were not. We thought space was empty, is not. Quantum fields ripple everywhere. We thought time was absolute. Stein showed it bends with speed and gravity. Reality is not a static answer. It is a moving frontier. The more we uncover, the more astonishing and unsettling it becomes. And maybe that is the true gift, not certainty. But wonder. The journey ahead. This video is an invitation. Over the next chapters, we will travel from the birth of atoms in ancient philosophy to the edge of modern physics. We will explore consciousness, perception, and the role of the observer. We will dive into radical theories like panpsychism, Halla movement, and the possibility that reality itself is a kind of simulation. Along the way, we will pause to marvel at surprising scientific facsimile windows that remind us just how strange the world really is. Our goal is not to give you a single final answer. No one has that. Instead, it is to give you the tools, the perspectives, and the questions to rethink reality for yourself, because, in the end, reality is not just out there, is also in here. In your awareness, in the very act of asking so. As we step into this journey, let us keep our minds open, our curiosity alive, and our assumptions ready to be challenged. Reality may not be what it seems. That is exactly why it is worth exploring. What if reality is not what we think it is, not even close? Every great breakthrough in human understanding has required a radical shift in perspective. Think of the moment when people first realized the Earth was not flat but round, not stationary but spinning through space. The shift was not just scientific. It was existential. It changed how humans saw themselves in relation to the cosmos. Suddenly, the ground beneath their feet was not the center of existence, but part of a much larger, mysterious whole. And this is exactly the kind of shift we face again today. Einstein and the flexibility of reality. And the early 20th century. Albert Einstein shattered the classical worldview with the theory of relativity. Until then, time was thought to be a universal flow, an invisible river, moving at the same pace everywhere. Space was thought to be a neutral stage on which events happened, but Einstein showed otherwise. Space and time are not separate. They are woven together into a single fabric, space-time, and this fabric bends. Gravity is not a mysterious force. Pulling objects, it is the warping of space-time. Itself, this discovery was more than just a clever mathematical trick. It told us that reality is flexible, relative, dependent on speed and mass. A clock ticking on a spaceship traveling near the speed of light does not match. A clock on Earth, time itself stretches and contracts depending on where you are and how you move. So ask yourself, if something as fundamental as time is not absolute, what else might be stranger than it appears? The invisible layers of reality, the visible universe stars. The galaxies, the planets makes up less than 5% of what we know exists. The rest, dark matter and dark energy, unseen, unknown, inferred only by their effects. The universe is dominated by ingredients that we cannot touch, taste, or see. That means the reality we experience. The world of trees and oceans and cities is a tiny sliver of the cosmic picture. Most of what exists is invisible. Think about that for a moment. We walk through our lives surrounded by a vast, unseen universe. Reality is not just what we perceive, it is also what hides in the shadows of our ignorance. Consciousness, the silent player, but let us turn inward. If physics and cosmology show us that reality is stranger than we thought, neuroscience and philosophy remind us that we cannot even define the reality of our own minds. What is consciousness? The fact that you are hearing these words right now, that there is an awareness behind your eyes, that you experience colors, thoughts, and emotions, that is consciousness. But no scientific theory fully explains how matter gives rise to this inner world. Some argue consciousness is just the brain's computation, neurons firing like circuits. Others suggest consciousness might be a fundamental property of the universe, like space and time themselves. A few even propose that consciousness, not matter, is the true ground of reality, that the physical world emerges from mind, not the other way around. If this sounds radical, remember 100 years ago. The idea that time could bend or that particles could exist in multiple places at once sounded equally absurd. And yet, here we are. The fragile nature of common sense. The problem is that human common sense is built for survival, not truth. Evolution shaped our senses to keep us alive, not to reveal reality in its raw form. The colors we see are only a tiny slice of the electromagnetic spectrum. The sounds we hear are a narrow band of vibrations. Even our perception of solidity is misleading. What feels like a hard surface is actually a storm of atoms repelling one another at microscopic distances. In other words, our brains are not cameras capturing reality. They are filters tuned for usefulness. We are prisoners of perception, and what we call reality may only be a user interface designed to help us navigate. This idea, both unsettling and liberating, forces us to ask, are we mistaking the map for the territory? The role of wonder at this point, you might feel overwhelmed. That is natural. To ask what reality is to open the largest, deepest, most vertigo-inducing question imaginable. But this is exactly why we should embrace wonder. Wonder is not ignorance, it's awareness of how much more there is to learn. It is the fuel of science, the spark of philosophy, the source of art. Without wonder, the universe becomes dull and mechanical. With wonder, every atom becomes a mystery, every moment a miracle. When we ask, what is reality made of? We are not only doing science, we are engaging in the oldest, most human act of all, looking up at the night sky and asking who we are, where we are, and why we are here. A map for the journey. So, here is what lies ahead in this exploration. We will travel back in time to the first thinkers who proposed that the world is made of atoms and follow the evolution of that idea into modern quantum mechanics. We will explore the strange nature of space, time, and the cosmos itself, discovering how relativity and quantum theory reshape our intuitions. We will dive into the enigma of consciousness and ask whether reality is fundamentally material or mental. We will examine radical theories from holographic universes to multiverse, speculations that push the boundaries of what reality might be. And we will uncover strange, lesser-known facts about the world around us, facts that challenge our sense of the ordinary and reveal the extraordinary. This will not be a simple story. It will be a journey, a conversation across centuries, between science and philosophy, between matter and mind. The invitation as we close this introduction. I invite you to step into this journey not as a passive listener, but as a participant. Ask your own questions. Let your assumptions be challenged. Allow yourself to be surprised, even unsettled, because reality is not a fixed object waiting to be pinned down. It is a living mystery. And the more we explore, the more we realize that to ask what is reality is not just to ask about atoms, stars, galaxies, is to ask about ourselves. So take a deep breath. Let curiosity guide you and prepare to see the world with new eyes. This is not just a lecture. It is an adventure into the very heart of existence. And now, let us begin. When we talk about reality, the conversation always seems to circle back to one concept: atoms. For centuries, humanity has wrestled with the question, what is everything made of? Atoms are the answer we found, or at least the closest answer so far. They are the scaffolding of the visible universe, the Lego bricks of existence. But the story of atoms is far stranger, more mysterious, and more profound than most people realize. Let's take a journey into the atomic world and uncover how these invisible structures became the foundation of our modern understanding of reality. The origins of the atomic idea, the notion of atoms, wasn't born in a laboratory but in the minds of ancient philosophers. Around 2,500 years ago, the Greek thinker Democritus proposed that all matter was made up of indivisible, indestructible units he called atomos, which literally means uncuttable. He had no microscopes, no experiments, and no evidence. But he had intuition. He believed that if you keep dividing matter, say, to a piece of bread, you will eventually reach a point where you can divide no further. That smallest piece would be the atom. For centuries, this idea was dismissed as philosophical speculation. Aristotle argued against it, claiming matter was continuous and could be divided infinitely. And because Aristotle's influence dominated Western thought, the atomic theory fell into obscurity for nearly 2 millennia. Atoms rediscovered. Fast forward to the 17th and 18th centuries, when experimental science began reshaping the world. John Dalton, an English scientist, revived the atomic theory in the early 1800s through his experiments with gases. Dalton concluded that matter must be made up of tiny particles atoms that combine in fixed ratios to form chemical compounds. This was the rebirth of the atom, not as philosophy, but as science. For the first time, atoms weren't just a thought experiment, they were becoming measurable and predictable. What exactly is an atom? At its simplest, an atom is a nucleus of protons and neutrons surrounded by a cloud of electrons. But this description, while accurate, hardly captures the weirdness inside. Protons are positively charged, and they determine the identity of the atom. 1 proton means hydrogen, 2 protons means helium, 6 protons means carbon, the basis of life itself. Neutrons are neutral particles that help stabilize the nucleus. Without them, the protons' positive charges would repel each other violently. Electrons are negatively charged, orbiting the nucleus in regions we call shells or clouds. These tiny particles define how atoms interact, bond, and form everything from water to DNA. Yet here's the shocking part. If you imagine an atom scaled up to the size of a football stadium, the nucleus would be a tiny marble sitting at the center, and the electrons would be specks of dust orbiting near the outer walls. The rest? Pure emptiness. That means everything you see around you, your chair, your screen, even your body is mostly empty space. Reality is far less solid than we instinctively believe. The quantum revolution for much of the 19th century. Atoms were considered the fundamental, indivisible building blocks of reality. But the 20th century shattered that illusion. Scientists discovered that atoms are not indivisible at all. They are worlds within worlds. Electrons, for instance, don't behave like neat little planets orbiting a sun. They exist in strange quantum states, simultaneously waves and particles, smeared out across probabilities rather than fixed positions. When we try to measure them, they seem to decide where to be. This leads us into the bizarre realm of quantum mechanics, where atoms stop being predictable objects and become clouds of possibilities. Reality at the atomic level is less like a machine and more like a cosmic lottery inside the nucleus. But the weirdness doesn't stop with electrons. Protons and neutrons, the seemingly solid core of the atom, are themselves made up of even smaller entities, quarks bound together by the strong nuclear force. Quarks are so strange that they never exist alone. They're always confined within larger particles. This means atoms are not truly fundamental. They are composites, layered structures of deeper reality. And every time physicists peel back a layer, they discover more questions than answers. Atoms and the illusion of solidity. If atoms are mostly empty space, why does the world feel solid? Why doesn't your hand pass through the table in front of you? The answer lies in the electromagnetic force. When you press your hand on a table, the electrons in your skin repel the electrons in the table's atoms. It's like two magnets pushing against each other. You never actually touch the table. What you feel as solid contact is simply the resistance of electromagnetic fields. In other words, solidity is an illusion. The universal alphabet. Atoms are the alphabet of the universe. With just about 92 naturally occurring elements, the cosmos writes its story. Hydrogen and helium fuel the stars. Carbon, oxygen, and nitrogen create the chemistry of life. Iron builds the cores of planets. Uranium fuels nuclear reactions. It's mind-blowing that all the complexity of existence, mountains, oceans, trees, humans arises from the endless rearrangement of just a handful of atomic types. It's like watching Shakespeare's plays written with only 26 letters of the alphabet. Atoms and consciousness. Now here's where things get even more fascinating. If atoms make up everything, then they also make up you. Your thoughts, your memories, your sense of identity all arise from atomic interactions in the brain. Neurons firing, neurotransmitters releasing, electrical charges moving across atomic networks. But does that mean consciousness is just atoms? Or is there something more? This remains one of the deepest mysteries in science and philosophy. Are we simply collections of matter obeying physical laws? Or is there an emergent quality, a spark of awareness that atoms alone cannot explain? The cosmic connection. Atoms are not just local building blocks. The atoms in your body were forged in stars. The carbon in your cells, the calcium in your bones, the iron in your blood, these were created in the fiery hearts of dying stars billions of years ago, then scattered across the cosmos in supernova explosions. Every atom of you has traveled across cosmic distances and epochs. You are literally made of stardust. Reality is not just built of atoms, it is connected by them across space and time. For a long time, atoms were thought to be the final stop on the journey into the fabric of reality, the smallest, indivisible, eternal building blocks of matter. But as we've seen, that picture began to crack. When physicists pried open the atom, they discovered something shocking. It wasn't indivisible at all. Inside the heart of every atom lies a zoo of smaller entities, particles, so strange, so elusive, that they almost seem to belong to another universe entirely. This is the subatomic world, a place where the rules of everyday reality break down. Here, matter is less like solid objects and more like ripples in an invisible ocean. To understand what reality is truly made of, we have to go deeper beyond atoms, into the realm of subatomic particles and quantum fields. The electron, a particle of mystery. Let's begin with the electron. It's one of the first subatomic particles ever discovered. In 1897 by J.J. Thomson. Electrons are tiny, incredibly light, and negatively charged. They orbit the atomic nucleus, shaping the chemical behavior of matter. But electrons refuse to fit neatly into our classical picture of particles. They behave like discrete particles one moment, and like smeared-out waves the next. This is the infamous wave-particle duality. If you fire electrons through a pair of slits, they create an interference pattern like waves of water, lest you observe them closely, at which point they suddenly behave like particles again. This experiment doesn't just confuse us, it forces us to ask, what is an electron really? Is it a thing? A probability cloud? Or something stranger that we simply don't yet have the language to describe? The nucleus, protons and neutrons moving inward, we find the atomic nucleus, a dense core that contains nearly all of the atom's mass. The nucleus is made up of protons and neutrons. Protons carry a positive charge, neutrons carry no charge. And together, they create the balance that holds atoms together. But why don't the protons, all positively charged, simply repel each other and blow the nucleus apart? The answer lies in one of the four fundamental forces of nature, the strong nuclear force. The strong force is mind-bogglingly powerful, over 100 times stronger than the electromagnetic force. It glues protons and neutrons together with an almost unimaginable grip. Without it, atoms couldn't exist, stars couldn't shine, and reality as we know it would unravel instantly. Quarks, smaller than small-even protons and neutrons, aren't fundamental. They are made of smaller particles called quarks. Quarks come in 6 varieties. Physicists call them flavors: up, down, charm, strange, top, and bottom. Protons, for example, are made of 2 up quarks and 1 down quark. Neutrons are made of 2 down quarks and 1 up quark. These quarks are bound together by particles called gluons, which act like the glue of the strong force. What's truly astonishing is that quarks never exist alone. They are permanently confined within protons, neutrons, or other exotic particles. Try to pull them apart, and the force binding them actually gets stronger. If you keep pulling, instead of isolating a single quark, you create new particles altogether. It's as though the universe itself refuses to let us see the raw ingredients of reality directly. The particles zoo by. The mid-20th century. Scientists discovered that protons, neutrons, and electrons were just the beginning. With the invention of particle accelerators, humanity began smashing atoms apart at near-light speeds. And what emerged was a bewildering array of particles: muons, neutrinos, mesons, bosons, and more. It became known as the particles zoo, hundreds of fleeting, unstable particles appearing for the briefest moments before decaying into something else. Physicists needed a way to make sense of this chaos. The answer came in the 1970s with what we now call the Standard Model of particle physics. It organizes the known fundamental particles into a kind of cosmic periodic table. Quarks, building blocks of protons and neutrons. Leptons, like electrons and neutrinos. Bosons, the force carriers, such as photons for electromagnetism. Gluons for the strong force. W and Z bosons for the weak force, and the Higgs boson, which gives particles mass. This model, though incomplete, is one of the most successful theories in all of science. It predicts experimental results with astonishing accuracy. Yet it also raises profound questions, because it doesn't explain everything. Neutrinos, ghost particles of the universe. Among the strangest subatomic particles are neutrinos. They are almost massless, electrically neutral, and interact so weakly with matter that trillions are passing through your body right now without leaving a trace. Neutrinos are born in nuclear reactions inside stars, in supernova. And even in the radioactive decay of elements on Earth, they are so elusive that they're often called ghost particles. Detecting them requires enormous underground detectors, filled with vast tanks of pure water or liquid scintillators, shielded from cosmic rays. Why care about these invisible ghosts? Because they hold secrets about how matter itself evolved in the early universe. Understanding neutrinos might help us answer why the universe has matter at all, instead of being annihilated by antimatter long ago. Quantum fields, the invisible fabric so far. We've been talking about particles as if they're tiny dots moving around. But modern physics paints an even stranger picture. Particles are not the fundamental reality. They are excitations of invisible fields that stretch across the universe. This is the idea of quantum field theory. Every particle corresponds to a field. The electron is a ripple in the electron field. Photons are ripples in the electromagnetic field. The Higgs boson is a ripple in the Higgs field, which pervades all of space and gives particles mass. Think of reality as a vast, invisible ocean. Particles are like the waves that rise up from its surface. They are temporary disturbances in something deeper and more fundamental. In this view, matter is not made of particles, made of fields, the vacuum that isn't empty, and here's where it gets mind-bending. Even the vacuum of space, the place we imagine as nothingness, is not truly empty. Quantum fields are always active, always fluctuating. Tiny pairs of particles and antiparticles constantly pop in and out of existence, borrowing energy from the vacuum before annihilating again. This quantum foam is seething beneath reality at all times. Far from being nothing, the vacuum might be the most energetic and dynamic place in the universe. Some theories even suggest that the birth of our universe itself, the Big Bang, may have been triggered by fluctuations in this quantum vacuum. The limits of our knowledge, despite the triumph of the Standard Model. Mysteries remain. Why is gravity missing from the model? Why is the Higgs field the value it is, and not something else? What is dark matter? The invisible substance making up most of the universe's mass. Every answer leads to new puzzles, and the deeper we look, the less solid reality seems. Instead of firm particles, we find probabilities, fields, and forces woven together into a tapestry of mystery. When we shift our perspective from the quantum world of particles and fields to the vast expanse of the cosmos, something extraordinary happens. The same rules that govern the tiniest building blocks of matter also shape the grand design of stars, galaxies, and everything in between. Reality is not only strange when we look small, it is equally astonishing when we look large. The universe, in a sense, is the ultimate expression of the invisible structures we explored in the subatomic world. Imagine stepping back from Earth, zooming out further and further until our planet shrinks to a pale blue dot, and eventually disappears into the glow of the Milky Way. At this scale, individual atoms and particles are irrelevant. Instead, we see the dance of stars, billions of suns bound together by gravity orbiting a galactic center. And yet, even here, the story of atoms persists. Every star is a factory of elements, smashing hydrogen into helium, building the very matter that will one day form planets and life. The cosmos is a laboratory, constantly turning the abstract rules of physics into breathtaking displays of light and structure. Stars are where reality forges its own building blocks. In their cores, under unimaginable pressure, atoms collide and fuse in nuclear reactions that release immense amounts of energy. This process, known as fusion, is what allows stars to shine. But it also creates new elements. The carbon in your body, the oxygen you breathe, the calcium in your bones, they were all born in the heart of long-dead stars. And when those stars reached the end of their lives, many of them exploded in violent supernova, scattering their enriched guts across space. Out of that cosmic debris, new solar systems emerged. Our Earth, our oceans, our very existence is possible because ancient stars lived and died. The universe is not just a stage for life, is its author. But the architecture of the cosmos is not just about stars. It's about the grand structures they form. Galaxies, for example, are sprawling cities of matter, some containing hundreds of billions of stars. They are connected by cosmic filaments, immense webs of dark matter and gas stretching across unimaginable distances. From far enough away, the universe doesn't look random at all. It looks like a vast, interconnected network threads of galaxies woven together, separated by enormous cosmic voids. Reality, on its largest scales, resembles something alive, like the neural networks in a brain or the tangled roots of a forest. What's even more mind-bending is that the same physics we see in the quantum world applies here too, though in different forms. Gravity, the weakest of the known forces, becomes the architect of the cosmos at large. It pulls matter together, sculpts galaxies, spins stars into spirals, and keeps planets locked in orbit. It is gravity that prevents the universe from being a meaningless soup of particles. Without it, matter would never gather into anything recognizable. Yet gravity itself is a mystery. Unlike the other forces, it does not fit neatly into the standard model of particle physics. We can describe it through Einstein's theory of general relativity, which tells us that gravity is not a force pulling objects together, but rather the warping of space and time by mass and energy. The Earth orbits the Sun not because the Sun pulls it with an invisible tether, but because the Sun bends the fabric of space-time, and Earth simply follows the curved path. This raises profound questions about the nature of reality. If space and time themselves can bend, stretch, and ripple like fabric, are they not also part of reality's building blocks? Perhaps atoms and particles are not the foundation of existence at all, but rather emergent phenomena arising from deeper, hidden layers of space-time itself. In fact, some modern theories suggest that reality may not be made of matter or energy at its core, but of information patterns encoded into the very geometry of the universe as we gaze outward. We also confront the vast mystery of dark matter. For decades, astronomers have observed that galaxies spin in ways that cannot be explained by visible matter alone. Something unseen, something invisible, must be holding them together. We call it dark matter, and though it makes up most of the matter in the universe, we still don't know what it actually is. It does not emit light, it does not absorb radiation, and it passes right through ordinary matter as if it weren't there. Entire galaxies are embedded in halos of this ghostly substance, and without it, the cosmos as we know it would fall apart. Dark matter is the scaffolding of reality, a silent architect shaping the cosmic web. And then there is an even stranger player, dark energy. In the late 1990s, scientists discovered that the universe is not only expanding, but that its expansion is accelerating. Something is pushing space apart, driving galaxies farther and farther away from each other. This mysterious force, which we call dark energy, makes up nearly 70% of the universe. And yet, we know almost nothing about it. If dark matter is the skeleton of the cosmos, dark energy is the breath that fills it, the invisible hand guiding its destiny. Here is the paradox. When we look at reality on its largest scale, we find that everything we can see, all the stars, planets, galaxies, and living beings, makes up only about 5% of the universe. The rest is invisible, untouchable, and deeply mysterious. That means that most of reality is not only hidden from us, is something we don't even have the tools to properly understand yet. The universe is, in a very real sense, mostly unknown. The cosmic architecture of reality reveals a pattern that repeats across scales. At the quantum level, particles are shaped by invisible fields. At the cosmic level, galaxies are shaped by invisible matter and energy. Reality, it seems, is never defined solely by what we can see. The visible world is only a small fraction of a larger, hidden structure that we are only beginning to uncover. And yet, the face of all this mystery, one thing becomes clear. We are part of this architecture. The atoms in our bodies were forged in stars. The forces that hold galaxies together also hold us here on Earth. The laws that shape the cosmos also shape our minds, our memories, and our sense of existence. We are not separate observers looking out at the universe. We are the universe, looking at itself. And so, as we continue our journey into reality, we leave behind the stars and galaxies for a new topic: time itself. Because if matter and energy define what the universe is, then time defines how the universe unfolds. What is time? Is it an absolute river flowing forward, or an illusion born from change? To explore reality fully, we must now turn to the enigma of time. When we look at the world with our eyes, what we perceive feels complete. We see the trees, the buildings, the faces of people we love, the light of the stars shimmering in the night sky. It feels whole, as if everything is fully given to us. Yet science has shown, again and again, that what we perceive is only a tiny sliver of what truly exists. Beneath the surface of reality lies an ocean of unseen layers, forces, and patterns, many of which remain invisible to our direct senses, but govern every aspect of our existence. To understand reality, then, is not just to look at what is in front of us, but to recognize what hides beyond the veil of ordinary experience. Consider light itself. Our eyes are tuned to a very narrow slice of the electromagnetic spectrum, what we call visible light. But this spectrum stretches far beyond what we can detect unaided. There are radio waves carrying invisible signals across continents, microwaves heating our food, infrared radiation that we feel as warmth, ultraviolet rays that tan or burn our skin, X-rays that reveal our bones, and gamma rays from the cosmos, powerful enough to disrupt DNA. All of these are forms of light, waves of energy oscillating through space. Yet our reality, as experienced by the human eye, is confined to a narrow band. The world we call visible is, in truth, an illusion born of limitation. But vision is not the only sense that deceives us. Our ears, tuned to frequencies between roughly 20 and 20,000 hertz, catch just a fraction of the symphony of sound. Elephants communicate with infrasonic vibrations below our threshold of hearing, while bats navigate with ultrasonic cries that to us are utterly silent. In essence, every species inhabits a slightly different reality, sculpted by the architecture of their senses. What feels absolute and universal to us: the look of the sky, the sound of a stream, the warmth of sunlight is only one version of reality, filtered by the peculiarities of our biology. And yet, reality extends even further beyond what any biological senses can capture. At the atomic scale, particles do not behave in the predictable, solid way our macroscopic world suggests. Instead, they exist as clouds of probability, their positions uncertain until measured. The table that feels so solid under your hand is, in truth, almost entirely empty space, its atoms held together by electromagnetic forces. If you could zoom in to a scale trillions of times smaller, you would find that solidity itself is an illusion. What feels like firmness is actually a field of repulsion between the atoms of your hand and the atoms of the table. The everyday sense of touch is, at its core, an interaction of invisible forces. When physics stripped away these illusions, it revealed something stranger. Reality is layered, structured, and often counterintuitive. Think of space-time itself. For millennia, humans assumed time was an ever-flowing river, absolute and uniform. But Einstein's theory of relativity shattered that assumption, showing that time bends, stretches, and warps depending on speed and gravity. An astronaut orbiting Earth experiences time differently than someone standing on its surface. Two people moving at different velocities or sitting at different distances from a massive, Star will not agree on the same now. Reality, therefore, does not unfold in a single shared timeline, but in a web of relative perspectives. The unseen layers extend even further into the cosmic scale. Galaxies spin faster than the gravity of visible matter can account for. Something else, invisible yet massive, must be exerting a gravitational pull. We call this dark matter, a substance that does not emit, absorb, or reflect light, and yet outweighs all the stars, planets, and gas we can see. Even more mysterious is dark energy, a force that seems to be driving the accelerated expansion of the universe. Together, dark matter and dark energy make up about 95% of the cosmos, meaning that everything we have ever seen with telescopes, everything we have ever touched or studied, amounts to less than 5% of reality. Imagine that for a moment. The reality we take for granted is only a tiny island floating in a vast, invisible ocean. But reality is not only built from matter and energy. There are emergent patterns, levels of organization that cannot be reduced to their parts. Think of life itself. A single atom has no awareness, no consciousness. Yet somehow, when arranged into cells, organs, and nervous systems, atoms give rise to beings who can think, feel, and ask questions about their own existence. Consciousness is perhaps the most profound unseen layer of reality, a force or substance in the traditional sense, but an emergent property of matter organized in a specific way. We cannot see thoughts in the same way we see light or matter, but we know they shape reality as surely as gravity does. Wars have been fought not over atoms, but over ideas, beliefs, and perceptions. In this sense, reality includes not only the physical, but the mental, the realm of experience that science still struggles to explain. Even memory becomes an unseen architecture of reality. The past exists for us not as atoms or forces, but as patterns encoded in neural connections, as traces preserved in photographs, as fossil imprints in stone. Reality for human beings is a tapestry woven not just from what is here and now, but from layers of time held in collective memory. Without memory, reality collapses into an eternal present, stripped of meaning. With memory, reality gains depth, continuity, and identity. If we take this further, one can argue that reality is not just what exists independently of us, but also what emerges through our interaction with it. Consider money. The paper bill or digital number in a bank account has little inherent value. It is the shared belief in its worth that gives it power. Nations' laws, social structures, all of these are invisible realities constructed and maintained by human agreement. They are not atoms or molecules, yet they shape the world we live in as profoundly as any mountain or river. Reality, then, exists on multiple levels: physical, biological, psychological, and social. Each layer is real in its own right, even if it cannot be reduced entirely to the one beneath it. The unseen layers of reality are reminders of humility. They tell us that our everyday perceptions are incomplete, that there is always more beyond the horizon of our senses and our current knowledge. We live in a reality richer and more complex than our ancestors ever imagined. Every time science peels back a layer, new mysteries appear beneath. We are like explorers in a vast jungle, uncovering one hidden trail only to find another leading deeper still. And so, to ask what reality is made of is not just to count atoms or measure forces. It is to recognize that reality is both seen and unseen, physical and mental, matter and meaning. The atoms that form our bodies are real, but so too are the invisible patterns of memory, the ideas that bind societies, the consciousness that reflects on its own existence. Reality is not a single layer, it is a multi-layered, ever-unfolding mystery. As we move forward, we will continue this exploration, peeling back yet another layer to uncover aspects of reality that challenge our assumptions and expand our sense of wonder. For the deeper we look, the more we realize the universe is not just stranger than we imagine, it is stranger than we can imagine. When we imagine the universe, most of us think first of matter planets, stars, galaxies, and the tangible stuff that seems to build everything we know. Yet beneath this picture lies a deeper truth. Matter is not the full story. In fact, matter itself cannot exist without energy. They are two sides of the same coin, woven together in an endless dance that shapes the cosmos. To understand reality, we must look not only at the solid, visible forms, but at the invisible flow of energy that gives those forms life. Albert Einstein's famous equation, E=mc, is perhaps the simplest and most profound expression of this truth. What it tells us is that mass and energy are interchangeable. The matter that makes up a grain of sand, a drop of water, or your own body is not fixed and inert, is potential energy locked in form. Under the right conditions, that matter can release unimaginable amounts of energy, as we see in the brilliance of nuclear reactions or the destructive power of atomic bombs. Likewise, pure energy can condense into matter, creating particles from light in high-energy collisions. In this way, the universe reveals itself not as a stage filled with static objects, but as a dynamic field where matter and energy are constantly transforming into one another. Consider the life of a star. A star begins as a cloud of gas and dust, drawn together by gravity until pressure ignites nuclear fusion at its core. In that moment, hydrogen atoms fuse into helium, releasing vast amounts of energy. The light and heat that stream from the star are energy born from matter itself, escaping into the cosmos. And yet, that energy does not vanish into nothingness. It travels, crossing light years, warming planets, driving winds, fueling photosynthesis in plants, and ultimately sustaining the fragile chain of life. Energy is never wasted. It flows, transforms, and takes new forms, but it is never destroyed. This is one of the fundamental laws of the universe, the conservation of energy. On Earth, every breath you take, every heartbeat, every thought in your brain is powered by this dance of matter and energy. The food you eat contains energy captured from sunlight by plants, energy stored in chemical bonds. When you eat, you break those bonds and release the energy, fueling the movement of your muscles, the firing of your neurons, the warmth of your skin. You are, in a very real sense, powered by starlight transformed into matter and then set free again as energy. Life itself is the story of energy flowing through matter, endlessly cycling and transforming. But the dance is not only about life. It is also about death, decay, and renewal. When stars exhaust their fuel, they collapse, sometimes exploding in supernova that scatter heavy elements into space. The iron in your blood, the calcium in your bones, the carbon in your cells all were forged in the hearts of ancient stars that lived and died long before Earth existed. Matter and energy cycled through those stars, and now, billions of years later, they cycle through you. You are literally made of stardust, a being of matter animated by energy. A fragment of the universe reflecting upon itself. At smaller scales, the dance grows even more mysterious. In the realm of quantum mechanics, particles are not just solid little balls of matter, but excitations of underlying fields of energy. An electron, for example, is a ripple in the electron field. A photon, a ripple in the electromagnetic field. In this view, reality is not built of tiny billiard balls bouncing around, but of vibrations, patterns, and waves in invisible fields. The solid world around us is, at its foundation, a kind of music of energy, a symphony of vibrations too small and too fast for us to see. Even the vacuum of space, once thought to be empty, turns out to seethe with energy. Quantum fluctuations constantly create and annihilate pairs of particles and antiparticles, flickering in and out of existence in unimaginably brief moments. This vacuum energy, though invisible, has measurable effects. influencing how particles interact and even contributing to the expansion of the universe. Reality, it seems, does not rest upon solid ground, but upon a restless ocean of energy, bubbling and shifting beneath everything we see. And then there is the profound mystery of entropy, the tendency of energy to spread out, to diffuse, to move from order to disorder. This principle, enshrined in the second law of thermodynamics, explains why heat flows from hot objects to cold ones, why stars eventually burn out, why time itself appears to move forward. Entropy is the arrow of time, the direction of energy's flow. Yet out of this tendency toward disorder, islands of complexity emerge. Life, consciousness, and even galaxies form by channeling energy in temporary, fragile patterns. In a universe tending toward chaos, order blooms briefly, beautifully before dissolving again. This dance between energy and matter is not only scientific, but also deeply poetic. It reminds us that nothing is truly separate, nothing truly static. The light that leaves a star may journey across billions of years before touching your eye. Yet, in that instant, the star and you are connected. The food you eat may contain energy captured from sunlight millions of years ago in ancient plants or more recently in crops grown on Earth. But in either case, that energy becomes you. To exist is to participate in the flow, to be a node in the great web where matter and energy endlessly intertwine, and the cycle continues. One day, the energy that animates your body will return to the earth, to the soil, to the atmosphere. Your atoms will scatter, your energy will disperse, and yet none of it will be lost. It will move on, shaping new forms, fueling new lives, perhaps even drifting into the cosmos to join the birth of new stars. In this way, the dance of energy and matter is not only the foundation of physics, but the story of transformation, continuity, and renewal. The deeper we look, the clearer it becomes that reality is not a static thing, but an ongoing process. Matter is frozen energy. Energy is liberated matter, and together they form the heartbeat of the cosmos. Every star in the sky, every drop of water, every thought in your mind is part of this eternal exchange. To ask what reality is made of is, in part, to recognize that it is not made of things but of relationships, transformations, and flows. Reality is not the stone. It is the river moving around it, shaping and reshaping. And so, when we try to understand our place in the universe, we must remember that we are not outside of this dance. We are it. The energy that burns in the heart of stars burns also in the human spirit, in the spark of curiosity that drives us to ask questions, to wonder, to dream. To understand reality is not to stand apart from it, but to realize that we are woven into its fabric, participants in the great and unending dance of energy and matter. Time is one of the most familiar aspects of our lives, and yet it remains one of the greatest mysteries of reality. We measure it in hours and days. We feel it in the rhythm of our heartbeats, and we watch it pass in the changing of the seasons. Time seems to flow like a river, carrying us relentlessly from the past into the future. But is time really what it seems? The deeper science looks, the more strange and elusive this hidden dimension becomes. At the everyday level, time feels linear and universal. The past is fixed, the present is fleeting, and the future lies open before us. Yet Albert Einstein's theory of relativity overturned this simple picture. He showed that time is not absolute, but relative, bending and stretching depending on speed and gravity. Imagine two twins. One stays on Earth while the other travels at near the speed of light in a spaceship. When the traveler returns, he will have aged less than his twin who remained on Earth. This is not science fiction, but a real effect confirmed by experiments. Time, it seems, does not tick at the same rate for everyone. It is woven into the fabric of space itself, creating what we call space-time. This means that time is not something separate from the universe. flowing around it like an invisible river. Instead, time is part of the structure of reality, inseparable from space, matter, and energy. A massive planet bends space-time, slowing down the flow of time nearby. A fast-moving particle experiences time more slowly than a stationary one. Even the ticking of your watch is affected, however slightly, by your position on Earth and your motion through space. What we call now is not universal, but depends on where you are and how you move. And yet, despite this scientific understanding, we cannot escape the feeling that time flows. The past feels gone, the future feels uncertain, and the present feels real. But physics does not describe time this way. In the equations of relativity, past, present, and future are all part of a four-dimensional structure. From that perspective, the universe is like a vast block of space-time where all events past, present, and future exist simultaneously. Our sense of time's flow may be less about the universe itself and more about how our minds perceive it. This leads to one of the deepest questions. Is time real, or is it an illusion? Some physicists argue that time, as we experience it, is a construct of consciousness, a way our brains order events to make sense of reality. Without consciousness, perhaps there is no now, no flowing river, only the static landscape of space-time. Others argue that time is indeed real, but far stranger than we can imagine. Either way, our everyday experience of time is not the full story. The mystery deepens when we look at the quantum world. At the smallest scales, the equations of quantum mechanics do not always seem to require time at all. Particles can exist in superpositions, their states undefined until measured, as if time itself does not apply in the same way it does at larger scales. Some physicists even suggest that time might emerge from more fundamental processes, like the entanglement of particles. In this view, time is not a basic ingredient of the universe, but a byproduct, something that arises from deeper layers of reality we do not yet understand. But while science challenges our notions of time, our lives are deeply shaped by it. We are born, we grow, we age, and we die. The arrow of time feels undeniable. And this arrow is closely tied to the concept of entropy, the tendency of energy to spread out, of order to decay into disorder. It is entropy that gives time its direction, that separates the past from the future. A glass can shatter into pieces, but those pieces will not spontaneously leap back into a glass. Heat flows from hot to cold, but never in reverse. Memory records the past, but not the future. Entropy is the deep reason we feel time moving forward. Yet even entropy raises new questions. If the universe is tending toward disorder, why did it begin in such an ordered state? The early universe was smooth, uniform, and low in entropy. Why? No one knows for certain. Perhaps this is simply the initial condition of reality, or perhaps it points to deeper laws we have yet to discover. What is clear is that the arrow of time is one of the central mysteries of existence, binding together physics, cosmology, and consciousness. Time also has a deeply human dimension. It is not just a measure of physical processes, but the stage on which our lives unfold. We experience it through memory, through anticipation, through the rhythm of days and years. Cultures across history have tried to understand time, to mark it with calendars and clocks, to find meaning in its passage. For some, time is cyclical, repeating in endless patterns. For others, it is linear, a journey from creation to an ultimate end. In both views, time is not just a scientific concept, but a fundamental part of how we make sense of our existence. And yet, no matter how we measure it or define it, time remains slippery. We can slow it down with speed or gravity, but we cannot stop it. We can imagine the past and dream of the future, but we live only in the present, which vanishes the moment we try to grasp it. Perhaps this is the ultimate lesson of time, that reality is not something we can fully capture or control, but something we must experience moment by moment. Still, The study of time continues to push science to its limits. Could time travel be possible? The equations of relativity suggest it might be under extreme conditions like wormholes or closed time-like curves. Yet paradoxes abound, and whether such travel could ever be realized remains uncertain. What is clear is that time is not the simple, linear, universal flow we once thought it was. It is flexible, relative, and deeply mysterious. In the end, time is both a scientific puzzle and a human reality. It is woven into the fabric of the cosmos and into the fabric of our lives. It shapes stars and galaxies, and it shapes our thoughts and dreams. To ask what reality is made of, we must reckon with time, not as a simple backdrop, but as one of the most profound dimensions of existence. And as we peel back the layers of reality, we find that time is not just something we live in, it is part of who we are. As we move from the external universe to the inner universe, we encounter one of the most profound mysteries of all: consciousness. Reality is not just what exists outside of us. It is also shaped by what exists inside. The atoms and energy that make up our bodies are part of the cosmos, yet something extraordinary happens when they are organized into a living brain. Awareness emerges. Thoughts, feelings, perceptions, and the sense of I arise from matter in motion. Consciousness is the hidden layer that transforms physical reality into lived experience. And understanding it may be the final frontier of science. Consciousness is a paradox. On one hand, it is utterly familiar. You experience it every moment through the simple act of existing. On the other hand, it is almost impossible to define or measure. Neuroscientists can map brain activity, identify neural networks, and trace the firing of neurons that correspond to specific actions or sensations. Yet none of this explains why subjective experience exists at all. Why does seeing a sunset or tasting chocolate feel like anything at all? Why does awareness accompany neural processes rather than being absent? This question is known as the hard problem of consciousness, and it challenges our deepest assumptions about reality. Some theories suggest that consciousness is an emergent property of complex systems. Just as wetness emerges from the interaction of countless water molecules, awareness emerges from the interaction of billions of neurons in the brain. Others propose that consciousness is more fundamental, perhaps even a basic feature of the universe, like space or time. In this view, awareness is not something the brain creates, but something the brain channels a lens through which the universe experiences itself. Consider the implications. If consciousness is fundamental, then reality is not purely objective. The world is not simply a collection of atoms and forces. It is also experienced, interpreted, and made meaningful by conscious minds. Our perception of color, sound, space, and time is not a direct reading of reality, but a translation. A constructed version tailored by our sensory organs and cognitive processes. Each of us inhabits a slightly different version of reality, filtered through our own consciousness. Even more intriguing is the connection between consciousness and observation at the quantum level. Experiments in quantum mechanics suggest that particles exist in states of probability until observed, at which point they collapse into a definite state. This does not mean human observation magically controls matter, but it raises fascinating questions about the role of awareness in shaping reality. Could consciousness be entwined with the universe in ways we barely understand? The idea is controversial, but it forces us to reconsider the line between the external and internal worlds. Consciousness also interacts with memory, imagination, and perception to create what we experience as reality. Your sense of identity, your understanding of cause and effect, and even your notion of past and future are constructed by your mind. Time, which seems to flow externally, is interpreted internally through memory and anticipation. The reality you inhabit is, therefore, a blend of external physical events and internal mental processes. The distinction between what is and what you experience is not always clear, and perhaps it never will be. Dreams offer another glimpse into this inner reality. While sleeping, our brains create entire worlds that feel real while we inhabit them. We see landscapes that do not exist, meet people who are not present, and experience emotions that are fully genuine. Dreams demonstrate that consciousness can generate reality independently of the physical environment, suggesting that awareness is not merely a passive observer, but an active participant in shaping experience. Some philosophers and scientists propose that consciousness is a spectrum, extending beyond humans to animals, plants, and even the universe itself. If the building blocks of matter can give rise to awareness in one arrangement, might they not give rise to forms of consciousness we cannot yet recognize in others? This idea stretches our understanding of what it means to be alive or aware, suggesting that reality might be more interconnected than we imagine. The study of consciousness also has practical consequences. Understanding how minds perceive and construct reality could revolutionize medicine, artificial intelligence, and even our social systems. We could better understand mental health, develop machines capable of empathy, and design environments that align more closely with human cognition. Consciousness is not an abstract curiosity. It is the lens through which all science, experience, and meaning are filtered. In this sense, reality is inseparable from consciousness. The universe exists, yes, but it is experienced through awareness. Without observers, the cosmos would continue according to physical laws. Yet it would lack meaning, narrative, and perception. Awareness transforms energy and matter into lived experience, turning the mechanical unfolding of the universe into something remarkable: life, thought, and reflection. And so, as we explore reality further, we must consider consciousness not as an add-on or a byproduct, but as a core dimension of existence. It is the inner reality that mirrors the outer universe, a personal cosmos reflecting the infinite complexity of the external one. To understand reality fully, we cannot stop at atoms, stars, or even time. We must venture into the mind itself, the hidden dimension where the universe comes alive in experience. Consciousness teaches us that reality is layered, interdependent, and participatory. The physical world provides the foundation, energy animates it, time gives it structure, and awareness imbues it with meaning. Each layer interacts with the others, creating a universe that is not only observed, but also lived, felt, and interpreted. The atoms in your body, the photons of sunlight, the fabric of space-time, they all converge in a conscious experience that is uniquely yours. Perhaps the ultimate lesson of consciousness is humility. Reality is not something we fully control or comprehend. It is a vast, interwoven tapestry of which we are both participants and observers. And yet, our awareness is also what allows us to marvel, to question, and to explore. The inner reality of consciousness is as vast and mysterious as the cosmos itself, reminding us that understanding the universe requires looking both outward to the stars and inward to the mind. As we journey deeper into reality, we encounter a realm far stranger than our everyday experience. World that defies intuition and challenges the very notion of what is possible. This is the quantum world, the domain of the extremely small, where particles behave in ways that seem impossible according to classical physics. Here, reality is no longer a collection of fixed objects, but a fluid interplay of probabilities, waves, and fields. To understand this level of reality is to see the universe not as solid and certain, but as dynamic, mysterious, and infinitely subtle in the quantum world. Particles do not have definite positions or velocities until they are measured. Instead, they exist in a superposition of all possible states simultaneously. An electron around a nucleus is not a tiny marble circling in a fixed orbit, as early atomic models suggested, but a cloud of probabilities where it might be found. This cloud represents potentiality, not certainty, revealing that reality at its core is governed by probabilities rather than absolutes. Perhaps the most famous demonstration of quantum strangeness is the double-slit experiment. When particles, such as electrons, are fired at a barrier with two openings, something extraordinary happens. If unobserved, each electron behaves like a wave, passing through both slits simultaneously and creating an interference pattern on a screen behind. Yet, if we try to measure which slit the electron passes through, suddenly behaves like a particle going through only one slit. Observation itself changes the behavior of reality, suggesting that consciousness and measurement play an essential role in shaping what occurs. At the quantum level, entanglement is another mind-bending phenomenon. When two particles become entangled, their states are linked regardless of distance. Measuring one instantly determines the state of the other, even if they are light years apart. Einstein famously called this spooky action at a distance because it defies classical ideas of locality and causality. Entanglement shows that particles are not always independent. They can exist in a network of relationships that transcends space, hinting at a universe more interconnected than we can fully grasp. Quantum mechanics also challenges our understanding of time and causality. Events at the quantum scale do not always unfold in a strictly sequential manner. Particles can appear to borrow energy from the vacuum for brief moments, or tunnel through barriers that would be insurmountable according to classical physics. These phenomena reveal that the microworld operates under rules that are probabilistic, relational, and often counterintuitive. The universe at its smallest scale is not a predictable machine, but a living web of possibility. Despite its strangeness, the quantum world is not merely theoretical. It has practical consequences that shape our reality. Semiconductors, lasers, MRI machines, and even the computers we use rely on principles of quantum mechanics. The very technology of our modern lives depends on exploiting phenomena that would have seemed magical or impossible to scientists just a century ago. The universe behaves differently at its tiniest scales, yet these behaviors ripple outward to affect the macroscopic world we inhabit. Quantum theory also raises profound philosophical questions. If reality is fundamentally probabilistic, what does that say about determinism? Are our choices predetermined by prior events, or do they emerge from a web of possibilities shaped by both chance and intention? The probabilistic nature of quantum mechanics suggests that uncertainty is built into the fabric of reality itself. While this does not give a free pass to wishful thinking, it does imply that the universe is not entirely fixed. Potentiality is as real as actuality. Moreover, quantum mechanics blurs the line between the observer and the observed. The act of measurement, or even interaction with a measuring device, affects the outcome. Reality at the quantum level is participatory. It cannot be fully separated from the act of observation. This concept resonates with consciousness studies, suggesting a deep link between awareness and the unfolding of events in the universe. In other words, our understanding of reality may depend not only on what exists, but also on how we interact with it. The quantum world also hints at multiple layers of reality beyond the familiar three dimensions of space and one of time. Some interpretations of quantum mechanics, such as the many worlds interpretation, propose that every possible outcome of a quantum event actually occurs, each in its own separate branch of reality. If true, the universe is not a single linear narrative, but a vast branching multiverse of possibilities. Each choice, each fluctuation at the quantum level, could give rise to new versions of reality existing alongside our own, unseen and inaccessible. Even more subtle is the idea that quantum fields, not particles, may be the true foundation of reality. Particles appear and disappear as excitations in these underlying fields, which permeate all space. In this view, reality is not a collection of things, but a continuous dynamic field of energy with matter emerging as temporary, localized patterns within it. The solid, tangible world we perceive is merely a manifestation of deeper, invisible processes occurring at every moment. These insights force us to reconsider what it means for something to exist. Is an electron real when it exists in superposition? Is a particle there if no one observes it? Quantum mechanics does not provide easy answers, but it challenges us to expand our concept of reality beyond everyday experience. The world we live in is only one layer, a projection of deeper, subtler processes that defy common sense yet underlie everything we see, touch, and measure. The implications extend beyond physics. Art, philosophy, and spirituality all grapple with the notion that reality is not fixed, that it is complex, probabilistic, and interconnected. Quantum mechanics invites us to question assumptions, embrace uncertainty, and recognize that the universe is far richer than we can perceive with our senses alone. Every particle, every field, every quantum fluctuation is part of an intricate dance that forms the foundation of existence. By exploring the quantum world, we gain more than scientific knowledge, we gain perspective. The solidity of matter, the reliability of cause and effect, even the passage of time itself are revealed to be contextual, contingent, and sometimes illusory. Reality is deeper, stranger, and more interconnected than our daily experience suggests. The universe at its smallest scales is a mysterious, wondrous place, revealing that existence is not just a static arrangement of atoms, but a dynamic, unfolding interplay of energy, possibility, and observation. In this way, the quantum world reminds us that reality is layered, participatory, and far stranger than it appears. It challenges us to rethink what it means to exist and to see ourselves as both observers and participants in the grand, unfolding story of the cosmos. And as we continue to explore, we realize that the universe has many hidden dimensions waiting to be discovered, waiting to reshape our understanding of everything we thought we knew. When we look up at the night sky, we see stars, planets, and galaxies stretching into the darkness. It feels infinite, eternal, and solid. Yet the true nature of space is far stranger than our eyes reveal. Space is not empty. It is a dynamic, flexible fabric, an intricate stage where matter, energy, and time interact. Understanding space is key to understanding reality itself. For the universe we observe is not merely a collection of objects, but a structure, a web, a living field of relationships that defies our everyday intuition. Space, as Einstein showed, is not a passive void. It is curved, warped, and stretched by the presence of matter and energy. Massive objects like stars and black holes bend the fabric of space, creating what we perceive as gravity. Planets orbit their suns not because an invisible force drags them, but because they follow the curves of spacetime. This is the essence of general relativity. Gravity is geometry, and space itself has a shape, a structure, a presence that influences everything within it. Even empty space teems with activity. Quantum physics reveals that what we once called a vacuum is actually a roiling sea of energy. Particles and antiparticles continuously flicker into and out of existence, creating fluctuations that, though brief and microscopic, have measurable consequences. These quantum fluctuations can influence the behavior of atoms, the formation of galaxies, and even the rate at which the universe expands. Space, it seems, is never truly empty. It is alive with potential, a medium through which the forces of reality are transmitted and transformed. Black holes offer one of the most extreme illustrations of the fabric of space. These regions, where gravity is so intense that not even light can escape, reveal that space can be stretched, warped, and compressed beyond ordinary comprehension. At the center of a black hole lies a singularity where our current understanding of physics breaks down. Space, time, and matter converge into a point of infinite density, a reminder that reality has limits to our understanding. Around black holes, space is not merely a container, but an active participant, shaping the paths of matter, energy, and even light itself. The expansion of the universe adds another layer to the mystery. Galaxies are moving away from one another, and the space between them stretches constantly. This is not motion through space, but an expansion of space itself. The farther away a galaxy is, the faster it appears to recede from us. This phenomenon, discovered by Edwin Hubble, suggests that the universe is not static, but growing, and the very fabric of space is stretching in a way that shapes the fate of all matter and energy. This expansion hints at the presence of dark energy, a mysterious force driving galaxies apart, which we do not yet fully understand. Cosmic inflation, the rapid expansion of the early universe, reveals that space itself can grow faster than the speed of light. This phenomenon, occurring in the first fractions of a second after the Big Bang, created the large-scale structure of the universe, seeding the distribution of galaxies we observe today. Space, therefore, is not a passive background but an active participant in the evolution of reality, expanding, stretching, and shaping the cosmos on a grand scale. Even the concept of distance is not as simple as it appears. Because space is curved, the shortest path between 2 points is not necessarily a straight line. Light traveling through the cosmos follows these curves, bending around massive objects in a phenomenon called gravitational lensing. This effect allows us to see galaxies that would otherwise be hidden and provides a window into the distribution of dark matter, an invisible substance that makes up most of the universe's mass. Space is not uniform. It is textured, layered, and shaped by forces we can only detect indirectly. Moreover, space interacts with time, energy, and matter in ways that challenge our intuition. Waves ripple through it, both gravitational and electromagnetic, carrying information across vast distances. Collisions between massive objects send shock waves through the cosmic fabric, detectable as minute distortions by instruments like LIGO. Space is elastic, responsive, and full of motion, even where no matter is present. It is a living stage, a dynamic medium through which the story of the universe unfolds at even larger scales. The structure of space reveals a cosmic web. Galaxies cluster along filaments separated by vast voids, forming an enormous network shaped by gravity, dark matter, and dark energy. These structures are not random. They are the emergent result of processes that stretch back to the very beginning of the universe. Space itself is organized, patterned, and interconnected, suggesting that reality is not chaotic but follows deep, underlying rules that govern the distribution of matter and energy. And yet, despite all we know, space remains mysterious. Its deepest properties, why it exists, why it has the dimensions it does, and why it is capable of harboring such complexity, remain unanswered questions. The study of cosmology, quantum field theory, and general relativity reveals that space is far from empty or passive. It is a medium of potential, a canvas for creation, and a participant in the unfolding drama of reality. In this way, the fabric of space reminds us that reality is not just what we see. It is a dynamic interplay of structure, energy, and possibility, stretching from the tiniest quantum fluctuations to the largest cosmic voids. Space is the stage on which the universe dances. Yet it is also a participant in that dance, shaping, guiding, and containing everything we know. Understanding space is therefore not just a scientific pursuit, is a journey into the very nature of existence itself. The deeper we look, the more we realize that reality is layered, interconnected, and profoundly intricate. Matter, energy, time, consciousness, and space are not separate entities, but facets of a single complex web. Each layer reveals new mysteries and deeper truths, inviting us to expand our understanding and embrace the astonishing richness of the universe. And as we peer into the depths of space, we are reminded that what seems empty is anything but. It is alive with structure, energy, and possibility, shaping reality at every scale, from the smallest particle to the largest galaxy. As we continue to peel back the layers of reality, we arrive at a remarkable point where simple particles and energy fields give rise to something astonishing: life. Life is not a separate phenomenon from physics and chemistry, but an emergent property of complex arrangements of matter. From the tiniest bacteria to sprawling ecosystems, life represents a level of organization and dynamism that seems almost magical when considered against the backdrop of atoms and molecules. Yet, life is the most tangible proof that the universe is not merely a collection of inert matter. It is capable of creating complexity, intelligence, and awareness at the most fundamental level. Life depends on chemistry. The carbon atom, with its 4 valence electrons, forms the backbone of organic molecules that make life possible. Chains of carbon combined with hydrogen, oxygen, nitrogen, and other elements assemble into proteins, nucleic acids, and lipids. These molecules are not random. They fold, interact, and replicate according to precise rules. Even the simplest cell is an intricate network of molecular machines, each performing a function that contributes to the survival and reproduction of the organism. From this perspective, life is a marvel of organized complexity arising from the fundamental properties of matter. Yet life is more than just molecules. It is self-organizing, adaptive, and responsive. Cells sense their environment, communicate, and change behavior to survive. Populations evolve over generations through natural selection, giving rise to the staggering diversity of species that inhabit our planet. Life is not a static phenomenon, but a dynamic process, constantly reshaping itself in response to internal and external forces. In this way, life is a bridge between the predictable rules of physics and the unpredictable unfolding of history. The emergence of consciousness within life adds an additional layer of complexity. While simple organisms respond to stimuli instinctively, more complex creatures exhibit awareness, learning, memory, and even creativity. Consciousness allows life to reflect on itself, to plan, to imagine, and to ask questions about the universe. This capacity for reflection is one of the most profound aspects of reality. The universe becomes aware of itself through living beings. Through consciousness, the cosmos is no longer just a mechanical system. It is experienced, interpreted, and made meaningful. Life also challenges our understanding of boundaries. Individual organisms are not isolated. They exist within ecosystems, interconnected networks of energy and matter. A forest, a coral reef, or a microbial mat represents a complex system where countless interactions create emergent properties that cannot be understood by examining components in isolation. This principle, known as emergence, applies at all levels from molecular networks within a cell to global ecological systems. Complexity, it seems, is a fundamental feature of reality, arising whenever sufficient interactions occur. The genetic code illustrates this beautifully. DNA stores information in sequences of nucleotides, encoding the instructions for building proteins and regulating cellular processes. Yet the code is flexible, subject to mutation, recombination, and epigenetic modifications. Life is both robust and adaptable, maintaining stability while allowing change. This balance between order and chaos mirrors patterns seen elsewhere in the universe. Stars form and die. Galaxies collide, and particles fluctuate in quantum fields. Life, in essence, is the universe learning to manage complexity, even at the level of behavior and social systems. Life exhibits patterns that echo physical principles. Flocks of birds, schools of fish, and colonies of ants organize themselves with astonishing efficiency. using local rules to create coherent global patterns. These patterns are reminiscent of self-organizing processes in physics, such as fluid dynamics or crystal formation, suggesting that the principles underlying complexity may be universal. Life is not an isolated anomaly. It is an expression of the same rules that govern matter, energy, and spatially. Biology also forces us to confront questions about probability and contingency. The emergence of life on Earth required a precise set of conditions: the presence of water, a stable star, the right chemical ingredients, and billions of years for evolution to unfold. Yet, once these conditions existed, the development of life was not inevitable in every detail. Evolution is contingent, shaped by chance mutations, environmental pressures, and historical events. The diversity and adaptability of life demonstrate that reality is not rigidly predetermined, but flexible, capable of producing novelty and surprise. The study of life also bridges the gap between the physical and the conscious. Biological systems are physical systems, yet they exhibit properties like adaptation, learning, and awareness that are not immediately apparent from the behavior of atoms and molecules. Life shows us that reality is layered. Atoms form molecules, molecules form cells, cells form organisms, and organisms form conscious systems capable of shaping their environment. Each level emerges from the one below, yet adds new properties and possibilities that cannot be reduced to simple sums. Life, in its complexity, also inspires wonder and humility. It reminds us that the universe is not merely a mechanical system, but a creative one. From the first replicating molecules to the vast diversity of ecosystems and the emergence of consciousness, life reveals that the cosmos is capable of producing structures that are self-organizing, adaptive, and meaningful. Understanding life requires integrating physics, chemistry, biology, and philosophy, showing us that reality is not compartmentalized but interconnected. Ultimately, life is a testament to the richness of reality. It demonstrates that atoms and molecules are not inert building blocks, but the seeds of complexity, capable of giving rise to systems that learn, adapt, and reflect. Life bridges the gap between the smallest scales and the largest, connecting quantum fluctuations to ecosystems, neural networks to societies, and consciousness to the cosmos. It is a vivid demonstration that reality is not merely matter in motion, but a dynamic, emergent, and participatory process. By studying life, we glimpse the principles that govern complexity, organization, and emergence. We see how simple rules can produce extraordinary outcomes, how matter and energy can give rise to systems capable of reflection, creativity, and adaptation. Life is not separate from reality. It is a fundamental expression of it, a lens through which we can explore the universe's capacity for novelty, intelligence, and meaning. As we continue to peel back the layers of reality, we arrive at a remarkable point where simple particles and energy fields give rise to something astonishing: life. Life is not a separate phenomenon from physics and chemistry, but an emergent property of complex arrangements of matter. From the tiniest bacteria to sprawling ecosystems, life represents a level of organization and dynamism that seems almost magical when considered against the backdrop of atoms and molecules. Yet, life is the most tangible proof that the universe is not merely a collection of inert matter. It is capable of creating complexity, intelligence, and awareness at the most fundamental level. Life depends on chemistry. The carbon atom, with its 4 valence electrons, forms the backbone of organic molecules that make life possible. Chains of carbon combined with hydrogen, oxygen, nitrogen, and other elements assemble into proteins, nucleic acids, and lipids. These molecules are not random. They fold, interact, and replicate according to precise rules. Even the simplest cell is an intricate network of molecular machines, each performing a function that contributes to the survival and reproduction of the organism. From this perspective, Life is a marvel of organized complexity arising from the fundamental properties of matter. Yet life is more than just molecules. It is self-organizing, adaptive, and responsive. Cells sense their environment, communicate, and change behavior to survive. Populations evolve over generations through natural selection, giving rise to the staggering diversity of species that inhabit our planet. Life is not a static phenomenon, but a dynamic process, constantly reshaping itself in response to internal and external forces. In this way, life is a bridge between the predictable rules of physics and the unpredictable unfolding of history. The emergence of consciousness within life adds an additional layer of complexity. While simple organisms respond to stimuli instinctively, more complex creatures exhibit awareness, learning, memory, and even creativity. Consciousness allows life to reflect on itself, to plan, to imagine, and to ask questions about the universe. This capacity for reflection is one of the most profound aspects of reality. The universe becomes aware of itself through living beings. Through consciousness, the cosmos is no longer just a mechanical system, it is experienced, interpreted, and made meaningful. Life also challenges our understanding of boundaries. Individual organisms are not isolated. They exist within ecosystems, interconnected networks of energy and matter. A forest, a coral reef, or a microbial mat represents a complex system where countless interactions create emergent properties that cannot be understood by examining components in isolation. This principle, known as emergence, applies at all levels from molecular networks within a cell to global ecological systems. Complexity, it seems, is a fundamental feature of reality, arising whenever sufficient interactions occur. The genetic code illustrates this beautifully. DNA stores information in sequences of nucleotides, encoding the instructions for building proteins and regulating cellular processes. Yet the code is flexible, subject to mutation, recombination, and epigenetic modifications. Life is both robust and adaptable, maintaining stability while allowing change. This balance between order and chaos mirrors patterns seen elsewhere in the universe. Stars form and die. Galaxies collide, and particles fluctuate in quantum fields. Life, in essence, is the universe learning to manage complexity, even at the level of behavior and social systems. Life exhibits patterns that echo physical principles. Flocks of birds, schools of fish, and colonies of ants organize themselves with astonishing efficiency, using local rules to create coherent global patterns. These patterns are reminiscent of self-organizing processes in physics, such as fluid dynamics or crystal formation, suggesting that the principles underlying complexity may be universal. Life is not an isolated anomaly. It is an expression of the same rules that govern matter, energy, and spatially. Biology also forces us to confront questions about probability and contingency. The emergence of life on Earth required a precise set of conditions: the presence of water, a stable star, the right chemical ingredients, and billions of years for evolution to unfold. Yet, once these conditions existed, the development of life was not inevitable in every detail. Evolution is contingent, shaped by chance mutations, environmental pressures, and historical events. The diversity and adaptability of life demonstrate that reality is not rigidly predetermined, but flexible, capable of producing novelty and surprise. The study of life also bridges the gap between the physical and the conscious. Biological systems are physical systems, yet they exhibit properties like adaptation, learning, and awareness that are not immediately apparent from the behavior of atoms and molecules. Life shows us that reality is layered. Atoms form molecules, molecules form cells, cells form organisms, and organisms form conscious systems capable of shaping their environment. Each level emerges from the one below, yet adds new properties and possibilities that cannot be reduced to simple sums. Life, in its complexity, also inspires wonder and humility. It reminds us that the universe is not merely a mechanical system, but a creative one. From the first replicating molecules to the vast diversity of ecosystems and the emergence of consciousness. Life reveals that the cosmos is capable of producing structures that are self-organizing, adaptive, and meaningful. Understanding life requires integrating physics, chemistry, biology, and philosophy, showing us that reality is not compartmentalized but interconnected. Ultimately, life is a testament to the richness of reality. It demonstrates that atoms and molecules are not inert building blocks, but the seeds of complexity, capable of giving rise to systems that learn, adapt, and reflect. Life bridges the gap between the smallest scales and the largest, connecting quantum fluctuations to ecosystems, neural networks to societies, and consciousness to the cosmos. It is a vivid demonstration that reality is not merely matter in motion, but a dynamic, emergent, and participatory process. By studying life, we glimpse the principles that govern complexity, organization, and emergence. We see how simple rules can produce extraordinary outcomes, how matter and energy can give rise to systems capable of reflection, creativity, and adaptation. Life is not separate from reality. It is a fundamental expression of it, a lens through which we can explore the universe's capacity for novelty, intelligence, and meaning. As we venture deeper into the essence of reality, we reach a realm that defies intuition, a world where the rules of classical physics no longer apply, the quantum domain. At scales smaller than atoms, the universe behaves in ways that seem paradoxical, strange, and almost magical. Understanding this subatomic world is essential to grasp the true nature of reality. Because the atoms that compose matter, the energy that drives change, and the forces that govern interactions all emerge from these quantum principles. The first remarkable feature of the quantum world is superposition. Unlike everyday objects, which exist in a single state at a given time, quantum particles can exist in multiple states simultaneously. An electron, for example, does not occupy a single point but a cloud of probabilities, existing in all allowed locations until a measurement is made. This is famously illustrated by Schrödinger's thought experiment with a cat, which is simultaneously alive and dead until observed. Superposition challenges the classical notion of a definite reality, suggesting that at the subatomic level, potentiality is as real as actuality. Closely related is the phenomenon of entanglement, which Albert Einstein famously called spooky action at a distance. When two particles become entangled, the state of one instantaneously affects the state of the other, no matter how far apart they are. Measurements performed on one particle immediately determine the outcome for its entangled partner, even across vast distances. This implies that the universe is interconnected at the deepest level, with correlations that transcend space and time. Entanglement hints at a hidden order, a web of connections that underlies the apparent separateness of objects in our everyday experience. The wave-particle duality of matter adds another layer of mystery. Particles such as electrons and photons exhibit both particle-like and wave-like behavior. Depending on how they are observed, they can interfere with themselves like waves, producing patterns that defy classical expectations. Yet, when measured, they appear as discrete particles. Reality, at the quantum level, is not fixed. It is shaped by interaction, observation, and context. This challenges the idea of an objective, independent universe, suggesting that the act of measurement is not passive but integral to the unfolding of phenomena. Quantum mechanics also introduces uncertainty. Werner Heisenberg's uncertainty principle states that certain pairs of properties, like a particle's position and momentum, cannot be known precisely at the same time. The more accurately we measure one, the less precisely we can know the other. This is not a limitation of our instruments, but a fundamental property of nature. Uncertainty implies that the universe is inherently probabilistic. and determinism gives way to a world where possibility and likelihood govern outcomes at the smallest scales. These phenomena are not merely abstract. They underpin the very fabric of reality. Quantum fluctuations in empty space can give rise to particles, influencing the early universe and the formation of galaxies. The stability of matter itself depends on quantum principles. The structure of atoms, chemical reactions, and even the behavior of light are governed by subatomic interactions. Without quantum mechanics, atoms would collapse, molecules could not form, and life as we know it would be impossible. Quantum theory also intersects with the concept of information. At the fundamental level, reality can be viewed as a network of information exchanges. The state of a particle encodes information about its properties, and interactions transmit, transform, and store this information. Entropy, the measure of disorder in a system, is closely tied to information, connecting thermodynamics, statistical mechanics, and quantum physics. Reality, therefore, is not only physical, but informational. A web of patterns and relationships that determine how matter and energy behave. The implications of quantum mechanics reach even further when we consider consciousness. Some interpretations of quantum theory suggest that observation is not merely passive, but actively participates in shaping reality. While controversial, these ideas provoke profound questions. Does consciousness influence the collapse of quantum possibilities into actual events? Are the mind and matter entangled in ways we do not yet understand? Regardless of the answer, quantum mechanics teaches us that the universe is stranger, more flexible, and more interconnected than classical intuition would allow. Quantum mechanics also reveals hidden symmetries in nature. Particles come in families, governed by fundamental forces that unify seemingly disparate phenomena. Electromagnetism, the strong and weak nuclear forces, and gravity emerge from underlying patterns that reveal a deep coherence in the cosmos. The search for a theory of everything seeks to uncover the ultimate unification, showing that reality, at its core, is elegant, structured, and mathematically coherent. Even chaos at larger scales often reflects order at the quantum level, hinting that complexity emerges from the simplicity of fundamental principles. Technological applications of quantum theory demonstrate its tangible power. Semiconductors, lasers, and superconductors rely on quantum behavior. Emerging technologies like quantum computing and quantum cryptography harness entanglement, superposition, and quantum interference to perform tasks beyond classical capabilities. These advances illustrate that the strange, counterintuitive rules of the subatomic world are not just theoretical, they are the foundation of the modern technological landscape. Finally, quantum mechanics challenges our philosophical understanding of reality. It forces us to confront questions of causality, determinism, and the nature of existence itself. Is the universe fundamentally probabilistic? Do multiple realities exist simultaneously in a vast quantum multiverse? How do observation, information, and interaction give rise to the concrete world we experience? These questions remind us that the closer we look, the more reality defies easy description, inviting curiosity, wonder, and humility in the quantum realm. We see that reality is not merely composed of atoms and molecules, nor is it purely deterministic. It is a fluid, probabilistic, interconnected network of possibilities, shaped by forces, information, and observation. Here, at the smallest scales, the universe reveals itself as both strange and profoundly coherent, a realm where the boundaries between potential and actual, observer and observed, matter and energy, dissolve into a subtle, intricate dance. By studying quantum mechanics, we understand that the very building blocks of reality are far more dynamic, mysterious, and interwoven than classical intuition would allow. The subatomic world teaches us that the universe is not a static stage, but an evolving, interconnected web of possibilities. It shows that at the core of reality lies not certainty, but wonder. Not simplicity, but intricate, astonishing complexity, inviting us to explore ever deeper into the mysteries of existence. As we explore reality further, we inevitably encounter the enigma of time. Time governs everything we experience, from the ticking of a clock to the lifespan of galaxies. Yet, despite its omnipresence, time is one of the most mysterious and debated aspects of the universe. Is time a fundamental property of reality, or is it a construct arising from our consciousness? Does it flow linearly, or is it an illusion shaped by perception and relativity? To understand reality at its deepest level, we must explore the nature of time itself. At first glance, time appears simple. Seconds pass, days turn into nights, and seasons change. But this apparent simplicity hides profound complexity. Albert Einstein's theory of relativity revealed that time is not absolute. It is relative, intertwined with space itself. Clocks in motion run slower than stationary clocks, and gravity warps the flow of time. A clock on Earth's surface ticks slightly differently than one aboard a satellite in orbit. This relativity implies that time is not a universal constant, but a dynamic dimension that responds to motion and mass. On the quantum scale, time becomes even stranger. Certain processes, such as particle decay, appear probabilistic, suggesting that events are not strictly predetermined. Some interpretations of quantum mechanics imply that the flow of time emerges from the interactions of particles and fields, rather than existing independently as a universal backdrop. In other words, time may be an emergent phenomenon, arising from the collective behavior of matter and energy at fundamental scales. Our perception of time is equally complex. Neuroscience shows that the brain constructs a sense of continuity, sequencing experiences to create the impression of a flowing present. Moments of fear, anticipation, or intense focus can distort our subjective experience of time, making seconds feel like minutes or hours seem to vanish. Memory plays a crucial role, linking past events with the present and creating a narrative continuity that shapes identity. Time, then, is not only a physical property, but also a psychological construct, intimately tied to consciousness. The arrow of time, the distinction between past and future, emerges from the second law of thermodynamics. Entropy, a measure of disorder, always increases in an isolated system, giving time a direction. This explains why broken eggs do not spontaneously reassemble, why heat flows from hot to cold, and why causality is preserved. Yet the underlying equations of physics are mostly symmetric. They do not inherently distinguish between forward and backward time. The arrow of time, therefore, arises not from fundamental laws, but from the statistical behavior of large systems. Cosmology deepens our understanding of time. The universe began with the Big Bang approximately 13.8 billion years ago, establishing the temporal framework for everything that followed. Galaxies formed, stars ignited, and planets coalesced within this unfolding timeline. Yet the distant future of the cosmos remains uncertain. Will the universe expand forever, cooling into darkness, or collapse back into a singularity? Our understanding of cosmic time highlights the interplay between physical laws, initial conditions, and the emergent properties of large-scale systems. Time also interacts with causality, a concept fundamental to how we understand reality. Cause and effect structure our experiences and allow us to predict and manipulate the world. But at quantum scales, apparent randomness challenges the simplicity of linear causality. Probabilistic events, entanglement, and uncertainty suggest that while macro-level causation is reliable, micro-level processes may be less deterministic. This duality reveals that time and causality are deeply intertwined, yet operate differently across scales. Philosophers have long debated whether time is real or an illusion. Presentism argues that only the present exists. The past is gone, and the future is yet to be. Eternalism, in contrast, suggests that all moments past, present, and future exist simultaneously, like pages in a book. From a quantum perspective, some interpretations of reality align with eternalism, where multiple timelines coexist as superpositions until observed or measured. The nature of time thus challenges not only physics, but also the way we understand existence, identity, and free will. Time also plays a critical role in life and evolution. Biological systems are intimately tied to temporal rhythms. Circadian cycles regulate sleep. Cellular processes follow precise timings, and evolution unfolds over geological timescales. Life experiences time differently at various scales, from the rapid firing of neurons to the slow drift of species across continents. This multi-scale temporal structure connects biology to physics, showing that time is not a singular, uniform dimension but a layered and dynamic phenomenon. The subjective experience of time shapes culture, art, and technology. Human civilizations have developed calendars, clocks, and temporal conventions to coordinate societies and transmit knowledge. Our perception of the past allows memory, storytelling, and history. Our anticipation of the future drives planning, creativity, and innovation. In this sense, time is not only a physical dimension, but also a social and cognitive framework that structures reality as we experience it. Emerging theories in physics suggest even more radical possibilities. Concepts like time loops, multiverse timelines, and quantum superpositions of temporal states hint that our conventional understanding may be limited. Reality could accommodate multiple overlapping temporal dimensions where cause and effect are not strictly linear. While speculative, these ideas challenge us to reconsider assumptions about what it means for events to happen and for moments to exist. Ultimately, time is a bridge connecting the microcosm and the macrocosm, the physical and the conscious. It shapes the evolution of the universe, the emergence of life, and the perception of self. It governs causality, entropy, and the unfolding of events. Yet, it is also constructed by consciousness, giving meaning to experience and continuity to identity. Time is neither fully understood nor fully separate from the observer. It is a dynamic, layered, and participatory aspect of reality. In studying time, we see that reality is not merely a static collection of objects, but a constantly unfolding process. The flow of time connects atoms to stars, neurons to societies, and moments of consciousness to the vast expanse of the cosmos. Time is at once external and internal, objective and subjective, deterministic and probabilistic. It is the thread that weaves existence into a coherent tapestry, allowing the universe to evolve, life to emerge, and consciousness to perceive. Time, like matter, energy, and consciousness, reveals that reality is more intricate, dynamic, and mysterious than it appears. To understand the universe, we must not only observe it, but also appreciate the ways in which time itself shapes every aspect of existence, from the smallest quantum event to the grand narrative of galaxies. As our journey through the depths of reality comes to a close, we arrive at a moment of reflection. Over the past chapters, we have traversed the very fabric of existence. From the tiniest atoms to the vast cosmos, from the mysteries of quantum mechanics to the enigma of consciousness. Each layer has revealed that reality is far more intricate, dynamic, and interconnected than our everyday perception allows. In this final chapter, we attempt to weave together the threads of knowledge, speculation, and wonder, revealing a unified vision of reality. At the foundation of everything lies the atomic and subatomic world. Matter, as we perceive it, is composed of atoms, which themselves are mostly empty space, with nuclei and electrons dancing in complex probabilistic patterns. But beneath the surface, the quantum realm challenges our notions of certainty and individuality. Particles exist in superpositions entangled across distances, and probabilistically interact in ways that defy classical intuition. From these behaviors emerges the material universe, a structure of staggering complexity built on fundamental principles that govern energy, force, and matter. Yet reality is not only composed of physical constituents. Consciousness, perception, and awareness form an equally essential dimension. Through consciousness, the universe becomes experienced. It is not merely a stage of atoms and energy, but a participatory system in which awareness shapes interpretation and meaning. The mind bridges scales, linking microcosmic phenomena with human experience, allowing us to reflect, imagine, and act. In this sense, reality is both objective and subjective. A tapestry woven from matter and mind alike. Time and causality further structure existence. The flow of moments, the increase of entropy, and the emergent arrow of time allow events to unfold in a coherent sequence. Yet even time is relative, shaped by motion, gravity, and perception. At quantum scales, linear causality gives way to probabilistic outcomes and entangled correlations, suggesting that the universe is simultaneously predictable and fundamentally uncertain. Conscious beings interpret, experience, and narrate this flow, converting mere sequence into meaningful history, memory, and identity. Throughout this exploration, we encounter interconnectedness at every level. Quantum entanglement shows that particles are linked across vast distances. Ecosystems reveal that life is a network of dependencies. Consciousness implies that awareness is not isolated, but part of a larger web of interactions. The universe is not a collection of isolated objects, but an intricate, interwoven system where every component, from the smallest electron to the largest star, participates in a cosmic dialogue. Philosophical reflection deepens this understanding. Reality is not a static thing, but a process, an unfolding of possibilities that emerge through interaction and observation. Ancient and modern philosophies converge in this idea, suggesting that the universe is alive in a subtle participatory sense. Whether through physics, biology, or awareness, we see that the universe is not merely experienced, is co-created by the very act of perception. This notion transforms our relationship with existence, inviting humility, wonder, and reverence for the complexity of being. Science provides tools, models, and frameworks, yet it also reveals the limits of knowledge. Theories evolve, new discoveries rewrite old assumptions, and each revelation uncovers deeper layers of mystery. Quantum mechanics, relativity, neuroscience, and cosmology illuminate the workings of reality. But they also raise profound questions about the ultimate nature of existence. Are there multiple universes, each with its own rules? Does consciousness extend beyond individual brains? Is reality an emergent phenomenon of information, perception, and interaction? These questions remain open, challenging us to explore further, think deeper, and embrace uncertainty as an integral part of understanding. From atoms to galaxies, from subatomic probabilities to conscious reflection, we see patterns of elegance and coherence. Symmetry underlies physical laws. Complexity emerges from simple rules. Life and mind arise from interactions at multiple scales. The universe exhibits both simplicity and intricacy, predictability and randomness, structure and freedom. Reality is, therefore, not a fixed object to be discovered, but a dynamic, participatory system to be experienced, explored, and understood at the human level. These insights have profound implications. Awareness of the interconnectedness of all things fosters empathy, responsibility, and creativity. Understanding the probabilistic and emergent nature of events invites humility and patience. Recognizing the deep mysteries of time, matter, and consciousness encourages curiosity, reflection, and continuous inquiry. Humanity, in its quest to understand reality, becomes not just an observer, but an active participant, shaping and interpreting the cosmos through thought, technology, and exploration. Technology itself, informed by quantum physics, neuroscience, and cosmology, allows humans to extend perception, manipulate energy, and probe the vast scales of existence. Satellites, particle accelerators, quantum computers, and telescopes are extensions of human consciousness, tools that amplify awareness and reveal the hidden structures of reality. These advances exemplify how understanding the fundamental principles of the universe can transform not only knowledge, but also experience and capability. Finally, the synthesis of these insights brings us to a profound realization. Reality is a multi-layered, dynamic interplay of matter, energy, time, and consciousness. It is neither fully objective nor entirely subjective, neither completely predictable nor utterly chaotic. It is a living tapestry of patterns, interactions, and possibilities, unfolding across scales from the infinitesimal to the cosmic. In contemplating this grand design, we glimpse the extraordinary complexity, beauty, and mystery of existence itself as we conclude this journey. We are reminded that understanding reality is not a final destination, but an ongoing exploration. Each discovery opens new questions. Each insight illuminates deeper mysteries. The universe, in its infinite richness, invites curiosity, wonder, and reverence. Whether we examine atoms, quantum fields, stars, or consciousness, the essence of reality is revealed as both tangible and enigmatic, knowable yet forever expanding in the end. The universe is more than what we perceive with our senses. It is a dance of particles and waves, of time and causality, of mind and matter. It is a story written in energy, information, and awareness. And as conscious beings, we are both witnesses and participants, shaping and experiencing the unfolding of existence. Reality is a vast, intricate symphony and endless interplay of being, perception, and wonder, and our journey through understanding it is just beginning.